Looking at the Math 2 Chapter 5 practice test. We start with our first problem. Find the sum of the measures of the interior angles of a 17-gon. So we want the total for the interior. Our rule is n minus 2 times 180. We go 17 minus 2 times 180. That gives us 15 times 180, which is 2,700. To find the measure of each exterior angle, we want each one, so we want the individual. We know the exterior total is 360. If it's an octagon, it has 8 sides. 360 divided by 8 is 45 degrees. Find the number of sides. So number of sides in a convex polygon whose interior angle sum is 3060. So here we go, 3060 equals n minus 2 times 180. If I divide 3060 by 180, I get 17 equals n minus 2. And then add 2 over and I get 19. So that would be a 19-gon. For number 4, find the number of sides for a regular polygon where the measure of each exterior angle is 7.5. Well, we notice that 360 is the total. It's going to be 7.5 times the number of sides that we have to get you 360. So if you divide 360 by 7.5, we get n is 48. So it is a 48-gon. Number 5, we're solving a hexagon here. A hexagon is 6 minus 2 times 180. To get the total, that comes out to be 720 degrees. So we say 720 equals 120 plus 95 plus 120 plus 125 plus x plus 84, and we're solving for x. Now should have 2 x's there. Oops, I forgot an x. So it's 720 equals 2x. I'm going to add up these values, 84, 120, 95, 120, and 125 to get 544. We now subtract 544 from our total, divide it by 2, and we get that x equals 88. For number 6, we need to find the value of each variable in our parallelogram. So I can set these two equal because they're opposite sides congruent. I can set those two equal, opposite sides are congruent. 6x equals 3x plus 15 becomes 3x equals 15 and x equals 5. Y plus 5 equals 2y minus 10 gives us y minus 10 on the right, 5 on the left. Add 10 over, we get y is 15 and x is 5. For number 7, we have a kite. Now for the kite, we have adjacent sides are congruent. So we can go 3x minus 7 equals x plus 7. I'm going to subtract x over and get 2x minus 7 equals 7. Add the 7 over, 14, so x is 7. I also have these opposite angles are congruent. So we'll go 4y equals 2y plus 60. We get 2y equals 60. And y is 30. And lastly we can do is classify, that is a kite. For number 8, this is going to be a trapezoid. In fact, an isosceles trapezoid because base angles are congruent. So I'm going to go 10x plus 15 equals 15x. That becomes 15 equals 5x, and x is 3. For number 9, we need to find the length of the diagonals in a square. Now, AE is this portion. BD is the whole thing. So our option is to take half of BD or double AE. So let's just double AE. So 2 times 3x plus 5 is really 2 times AE, which is AC, which is equal to BD. So by doubling that, 6x plus 10, I can say 6x plus 10 equals 10x plus 2. Subtract 6x, subtract 2, 4x equals 8. So x equals 2. But they want the length of the diagonals. I can plug that into either of these. I'm just going to plug into there. So that's going to be 10 times 2 plus 2 is 22 units. For number 10, can we conclude if it's a parallelogram, rhombus, rectangle, or square? Well, we know it's a parallelogram. They gave us that. Since the diagonal bisects angles, that's going to tell us we're going to go rhombus. And that's because we have 41, 41, 41, 41. Now, if the 41s added together to be 90, we would say it could be a rectangle. In that case, it would also be a square. But since we only know that much, we're going to stop at rhombus. For 11, we have angle CAD in the rectangle is 43 degrees. We need to find all other angles. Now, I know in a rectangle that diagonals bisect each other. They're also congruent. So if that's 43, I also have a 43 here. We can also use the fact that the angles add up to 90 degrees. So this is 47, which we can match over to 47. 47 here matches to 47. Then we go 43, 43. Last thing we have is those central angles. Now, 43 and 43 is 86. 180 minus 86, because it is a triangle, is 94. We have its vertical angles 94. Then the angles next to those is 180 minus 94, which is 86. For number 12, QRST is an isosceles trapezoid, so we'll mark that as such. If we know that, we have same side interior angles here, so that's 180 minus 116, gives me 64. And then I can go across to the other side, and that's going to be congruent angles because it is an isosceles trapezoid. So we would say that Q was 64 degrees, T was 64 degrees, and S was 116. For number 13, we need the mid-segment of our trapezoid. Now this mid-segment is equal to the average of the bases. So 12 equals 5x minus 4 plus 8x plus 2 divided by 2. That's finding the average. To clear out the 2, I'm just going to multiply the 2 over, make that 24 equals 5x minus 4 plus 8x plus 2. This is 24 equals 13x minus 2. We get 26 equals 13x, so x is 2. We could go back, check our answers. Up here, that becomes 6. Down here, that becomes 14. And if we look here, oops, that should be 16, that'd be 20. There we go. 6 and 20, 12 is in the middle. It is for the mid segment. For number 14, we have a kite. We need the measure of angle RPT, which is right here. Now in a kite, I know diagonals are perpendicular, so this gives me two right triangles between these two. They're congruent by a reflection. So if I have 90 here and 34, 90 minus 34 gives me the other angle, which is 56. And I can go across to angle RPT, which is also 56 degrees. For number 15, we need to classify as precisely as possible. This will be a kite because it has adjacent sides congruent, but not opposite. I should say two sets of adjacent sides congruent, but not opposite sides. We have the two sets here, two sets here. Now this one, I got diagonals bisect each other, so it could be a parallelogram, but they're also perpendicular. So the fact they're perpendicular makes this a rhombus, and that's because I have diagonals perpendicular and they bisect each other. Now if I just had the bisect each other, we would stop at parallelogram, but since we qualified it as a parallelogram and we could go forward to make it a rhombus, diagonals perpendicular works for us. The last one here is a square. That's because I have 4 congruent sides and 4 congruent angles. The congruent sides qualify it as a rhombus, the congruent angles qualify it as a rectangle. Rhombus, rectangle gives you square. For 16, I have some points here. I need to find point M. Now if I notice in my parallelogram, it goes A units over. So up here to get to N, it went A plus B to get the whole distance. Well, this distance here is still A, so in fact this little part right here is going to be B. How much I went up is the same, that is C. So now I want to find the midpoints of the diagonals. We draw these in. The midpoint of, we'll go MP, is add the x's, divide by 2. That's going to be a plus b over 2. Add the y's, divide by 2, c plus 0 over 2. We get a plus b over 2, c over 2. Now for our other point, we'll call that ON, with the midpoint, we get 0 plus a plus b, or just write a plus b over 2, and then 0 plus c over 2. We get that midpoint. Now we notice these two things are the same. That means that the midpoints are the same point on each diagonal. That would indicate that the diagonals bisect each other. And that is one of our properties to get a parallelogram. For 17, I'm going to plot some points here. I got back one, up one is 1 point. Over 1, up 4. Over 5, up 1. And 3, down 2. Let's just approximate right there. So I have my shape here. I'm going to write in the coordinates. Now, one way we can go and show this is a parallelogram is show that opposite sides are parallel. To do that, I'm going to look at their slopes. So this slope here, it went up 3 over 2, so that's 3 over 2. Down here, it went up 3 over 2, that's 3 over 2. The slope for this side, it went down 3 over 4. Here it went down 3 over 4. So I see I have slopes of -3, 4, and 3 over 2, so we know opposite sides are parallel. That means we got a parallelogram. Another option is to look at diagonals bisect each other, and that's where we're going to take midpoints. So we're going to go use these 2 points. We get 1 plus 3 over 2, 4 minus 2 over 2. This gives us 4 over 2 and 2 over 2, so our answer is 2, 1. And our midpoint for these two is going to be -1 plus 5 over 2 and 1 plus 1 over 2. And this becomes 4 over 2, 2 over 2, which is 2, 1. So the fact the midpoints are at the same point, it tells us the diagonals bisect each other. The final option you could do is use distance formula, but that would be a little bit messy. I would go through and just show opposite sides parallel, or even that fact that diagonals bisect each other.